was a lot of presentations. Thank you so much. And thank you for everyone who's still online. We're gonna take about 10 minutes. We have we have about 10 minutes for question and answer. So if you have a question, please put it into the Q&A. And I'll turn this around. That was
are they consistently thick, the slices? Are they always the same? Or are you assuming that they're the same thickness when you all read the code?
In the case of the one I did here, yes, they're always the thickness. The slice thickness is typical of this preparator. Every slice has the same slice thickness, and usually the number, like range of numbers of slices on it. So it's really meticulously. Other slides that I've looked at are results show.
Okay, thank you.
Question two for John. Did you try throwing those image sets through the photogrammetry software? Because a lot of like reality capture uses SIFT to do alignments, and was wondering if, I don't know, have you tried any of that? I was just curious what some of the results might be.
I would be too. I didn't try any photogrammetry software. I tried some really initial exploratory data sets with Mira, which has some alignment capabilities and whatever, and kind of ran into the sort of same similar problems to using ImageJ. It's a lot of trial and error, and you get different results depending on which reference image you choose. And yeah.
I'll try it for you.
Okay.
We can just plug it in.
Yeah. Okay.
Yeah, cool.
Question for you. You're noting for your staining. Did you know the differences staining for 5% versus 40%?
sorry. Can you say that a little louder so they can hear you over?
I was asking if the preparation type, the fixation preparation type for wet specimens, if it's 95% versus like strictly versus the combination of formalin with an ethanol type impacted how well the iodine is staining.
Yeah, so unfortunately, I don't even have access to that information. So this preservation history most of the time is unknown. Like right now, I know they're all at 70% ethanol. I know that much, but there's no record of like whether it's formalin fixed or ethanol fixed. And that's something that like with the dye-CT, a future investigation that I would like to do would be to like purposely try different fixing methods, but also purposely like treat things the way that you shouldn't do it. So there are a few things like multiple freeze-thaw cycles can really affect tissue quality. Having a gap between when the thing died and when it was fixed, those kinds of things where like I can look at a scan and say it's poor quality and it might be because of this, but I don't know because I don't know what caused it. So that is a future direction that I would love to go.
Are there any online questions? I had a question for JJ. So you might have mentioned this in the beginning, but it seemed like there was a lot of issues with doing the CT scans for the reconstruction, at least with like the pigment and the issues of, some degradation of color, stuff like that. So going back, would you try maybe just utilizing photogrammetry and light scanner? Like, was the internal information really?
So the objects were originally, or I think they were actually they did photogrammetry and they did imagery, traditional imagery, but the problem is, I didn't get to talk a lot about it, is the functionality. So these are dance whistles they're not made by blowing, like they're made by blowing, and then they're also being used during a ceremony that they're dancing and moving around with. So for functionality, they really, for the milling purposes, needed to see the interior of the objects, but they couldn't take them apart, and so that's why we ended up using CT. The problem we had was paint was the problem, because with biological specimens, most of the time, you're not having to worry about if there's like impacts on the scales, because you're not looking, unless you're looking specifically at that, you're not you're not looking at that. So for the cultural items and the ceremonial objects, paint was a prominent factor. So in, there's also like research on papyrus scrolls as well as in Egyptian research with paints on the outside of sarcophaguses. You know, you all have to think about that. It was just an extra step that we did to just make sure we weren't going to alter the objects. The scanning itself relatively was easy. And then we did that substrate analysis to just reconfirm and also to do test parameters. So we did it at like 90 kV, we do it at like 130 kV. Upwards up just to test the parameters to see which one would be best used. So I think they were traditionally photogrammetry and images were taken. They wanted to know the functionality. We would have never known they were river stones. They thought they were beads because that was traditionally what was used inside the rattles.
I really enjoyed those talks, just brought together some research applications I'd never thought of before. So I have a question for Mateo. The 900 embryos you found, were those all reserve specimens of the museum?
Not all of them, but the majority of them.
Okay.
So regarding alligators, turtles, chicken, model more reasonable organisms, I managed to get the eggs, and then I fixed them in an oven, and it's exactly the problem having fresh samples. Regarding primates, cetaceans, so on.
So I assume we get the embryo data, the specimen was scanned. They weren't scanned for you to do your work, they already scanned.
No. I went there
Okay, so you
to
were looking
scan
for
them
pregnant
for
and
my
over
work.
something like
Yes. And the idea is that you can still do it in museums.
Right.
The main point is, although my interest in selecting samples was driven by my research, I know that this could be a project, a collaborative project for the next 5 years that could really bridge the two things.
Right.
Because obviously I'm just one, so I'm prioritizing what I need. This could become a resource for everyone because there are very few labs doing this kind of work. And one of the main reasons is that having animals in the lab is extremely expensive and the sample in the tree is extremely low.
Because I was thinking this for some taxa, it may be easier to tell the specimen during an embryo.
Yes.
Far along in pregnancy. For others, not. I mean, discovering maternal embryos, surprise. So I'm just wondering if there's some like pre-screen.
The best way to pre-screen is to see if specimens were dissected before. There are many researchers who just went to think about liver and lungs and stuff like that, and never paid attention to what was inside the specimen. So, like a few years ago, I asked to scan this adult sphenodon that was regrowing the tail, thinking that the tail was cool and urine, and then it comes out that the sphenodon is completely ovulated. So it has those insulins and the protection similar to the tissue. Yes, so you can never know, but I think it's good.
We have a question online and it is, where can you find information on the setup/operation of Sugar?
Sugar has a GitHub page, just Google Sugar and GitHub. There is pretty decent documentation on it, it's a little tricky. There is also a thing called SDF Studio, which also has a GitHub that I might actually recommend over Sugar that we found later in our process that has a lot more of that interoperability kind of built into it, a bunch of algorithms. So you can test like news against Sugar pretty quickly. So yeah, SDF Studio on GitHub.
Yeah. And in case you didn't hear that, I will say it louder, closer to the microphone. There's a Sugar GitHub, and you can also look at SDFS, which is something that was found a little bit later. in their process than sugar.
Yeah, okay, we're gonna take a hour break for lunch. We'll leave we'll leave the Zoom open, and then we'll be back at 1:30 this afternoon with Nick Pyenson. So thank you for everyone who joined this morning, and thank you to our speakers. Start.